Okay, so we need to show that these are parallel. Remember, the condition for parallel is if one vector is like a multiple of another vector. If you can do that, if you can prove that, in other words, if I had one vector m and it's a multiple, okay, where k is a constant of another vector, if I can prove that, okay, is a constant, then it leads to them being parallel, okay. Now I can show that's the case here, because if you just stare at these for a minute, we can actually see that this vector here is bigger than that vector by a certain factor, okay. So you just go think, well, okay, this is bigger. What do I do to this to get that? What do I times it by? Well, it's not quite double, isn't it? In fact, 1.5 times the size, isn't it? 9 is 1.5 times the size of 6, and the same we could say for 12. It got to be constant, right? So if 9 here is 1.5 times the 6, the same has got to be true for the other part of the vector. That's got to be 1.5 times the size of it for it to be parallel. So we can say that there. We can actually prove. We can say, look, 9a plus 12b is 1.5 times. Okay, so 3/2 times the other vector. We times both of them by 1.5. You get this here. So therefore, they are parallel.